Before I start, let me recognize Tyler Moynihan as in the blue shirt in the back row. That's my graduate assistant. They give us graduate assistants in the university, and of course without his assistance I wouldn't have as complete a presentation as I do have, so thank you very much. He's here with his father, he's visiting for Thanksgiving. What I thought I would do is tell some old stories in a new context, particularly in the context of innovation, and set a framework for trying to understand what factors give rise to innovation, particularly in the space program, though I've thrown in examples from some other areas as well, such as energy. And the big question behind all of this is governmental innovation an oxymoron? Is government capable of innovation? My thesis, after looking at this for a couple months, is that yes, it is, but it is as hard as rocket science. The things that you would not want to do wrong in rocket science, you would not want to do wrong if you were undertaking innovation. Let me start by trying to reframe models of innovation and then look at factors that are thought to influence innovation. We'll have some case examples, summary and a conclusion. It shouldn't take more than 25 or so minutes, and then at that point we can have a discussion among ourselves and frame this. So let's take a look at the first slide. Here's the basic problem. Most of our models of innovation in space policy are linear. Most of the good economic models of innovation in that discipline are nonlinear. What do I mean by a linear model? Well, it's the idea if you change one thing that downstream you get some other change. Like, for example, if we spend money on space, we get jobs, which means more students go to school, get education in engineering and science, and that in turn results in progress and economic growth. That's a linear model. I think the spin-off argument that NASA makes is a very valuable argument, but it's a linear model as well, with some of the main characteristics. The best models of innovation aren't linear. And why aren't they linear? Well, because if you just assume you're creating jobs, it doesn't tell you what kinds of jobs you're creating. You may be creating jobs for skilled workers, you may be creating jobs for unskilled workers. The nonlinear models help you focus on that. So what does a nonlinear model look like? Well, for this I'm indebted to Julia Lane of the National Science Foundation, because she has developed argument that science programs should be evaluated on the basis of nonlinear economic models. To understand a nonlinear economic model, just look at one of those curves and think of a factor like labor. That'd be an easy one to look at. You could think of physical capital, how much money are you putting in to buy things that are physical. If you spend too little money on physical capital, you're not going to get a very good science program. But at the opposite end, if you spend too much money on physical capital, you're going to get waste. So what the economists say is that the shape of the factor of physical capital is sort of bell-shaped. And that means that there's an optimal point of spending to accomplish a given mission. And that works both for the average input of a factor, like physical capital, and it also works for the marginal input. The two together create the curve at the top, which tells you how much science you're getting or how much exploration you're getting for a given input of physical capital. And then somebody who's engaged in that, particularly in the private enterprise, will use the calculation in their head to figure out how much physical capital, how much labor, how much energy, and how much land to use in order to produce the output. If that's too much economics, it's like Moore's Law. And Moore's Law is repeated up there on the board. I think you can read it, but basically it says that every 2 years you're going to get tremendous advances in the capacity of computers and microchips to handle information. So that over periods of time, as technology plays a role in labor and physical capital and other factors, it causes the curves to peak, to rise. And that's what I think we ought to be focusing on, is whether or not we're getting, if I can use the military phrase, more bang for the buck. Is technology having an effect on the use of physical capital, labor, and other factors of production for spaceflight that gives rise to progress, which in turn gives rise to economic growth. That's what we're hoping to do. And so if we look at old stories in that way, I think it helps to understand whether or not innovation is taking place as we move through the spectrum of programs. In order to prepare for this presentation, Tyler and I went and looked at university programs that exist for innovation and science and technology. There are a lot of innovation programs now at universities and a lot of self-help books and some serious ones that deal with innovation. These are some of the factors that are taught in the course as contributing to innovation. The programs are located all over the modern university. There's no discipline of innovation that you can find with an academic department nicely ensconced in a school of arts and sciences or public affairs or business. So they're all over the place. At Stanford, it's in the School of Design. Sometimes you find them in the engineering schools. Sometimes you find them just free-floating in the universities. But they do have this common element that they identify factors that are associated with innovation. Here's, I think, 11 of the top factors. I'm not going to do all 11. But I thought we could look at the first 4, which you consistently hear about in studies of innovation, that a clear sense of purpose, an ability to take risks, technical discretion, and I could not resist putting in imagination, have a bearing on whether or not innovation occurs. So I thought the interesting thing to do would be to look at each of these, put some old stories in the framework of these 4 factors, and see how that allows us to analyze the ability of government to act as an innovator, or, or to spur innovation. So let's start with a sense of purpose. The model says, under sense of purpose, that a commitment to purpose prompts investment in technologies to overcome obstacles. What in the world does that mean? During Project Apollo, the United States, and NASA in particular, was challenged to go to the moon with a budget that was fixed. The idea that NASA had all the money it wants or wanted was a myth. They didn't, and there were budget fights in the White House that almost resulted in the discontinuation of the ultimate goal of reaching the moon by 1970. So NASA had a fixed budget, it had too little time, and the rocket that was designed to take astronauts to the moon was too small. That is, the rocket that was capable of getting astronauts to the moon by 1970 was the Saturn V, but Wernher von Braun wanted NASA to develop a Nova rocket that could lift a larger payload into low Earth orbit, but you couldn't get to the moon by 1970, which was the purpose that was keeping the money flowing from the White House, if you used the larger rocket, which was the better rocket von Braun thought, but harder to develop. With that in mind, NASA proceeded to innovate in a number of very clever ways. The most innovative, I thought, was the decision to adopt Lunar Orbit Rendezvous as the methodology for reaching the moon, which allowed NASA to go to the moon with a Saturn V rocket that could deliver 118,000 pounds of kilograms into low Earth orbit. It also resulted, this is sort of amusing, in the development of the Apollo guidance computer. I remember being at the Johnson Space Center and looking at the room that held the guidance computers for the ground control operation, and they filled an office building. Now, how do you get that onto a spaceship that has to use a computer to land? Stories have been told about that very effectively with books in the NASA History Office, and basically what we came up with was the Apollo guidance computer, a miraculous development and innovation at that time, because it weighed only 32 kilograms. If you can imagine that, a computer that weighs as much as a chair. But that was what was developed in order to keep within the weight requirements. So it's often thought, to take the phrase, do we want to go to the moon or not, that a sense of purpose gave rise to innovation in the Apollo space program because of the constraints involved. Now let me take a case where at least one person believes that innovation did not occur. There we are at the Air and Space Museum in 1989, as the first President Bush introduces the Space Exploration Initiative. Certain people in the White House, and I'll make a plug for Mark Albrecht's book here, Falling Back to Earth, certain people in the White House believed that that gave NASA an opportunity for innovation. And they received proposals from institutions like Livermore Labs for new and unique ways to get back to the moon and to go on to Mars. Inflatable spacecraft, which we don't call inflatable anymore, they're expandable. Advanced propulsion systems. Autonomous operations that didn't require as much ground control. People in the White House believed that NASA had a golden opportunity to move forward with a different space program that utilized different technologies if only they were committed to the purpose that was set out in that 1989 speech. And they were bitter that NASA's response was different than to innovate, that this was a case of non-innovation, according to Albrecht. A few months after President Bush made this speech, the Berlin Wall fell, and the Cold War ended. People in the defense community and in space and in the aerospace business had to make a critical decision. What did they do when they were confronted with a loss of purpose for their programs? One alternative would be to find a new purpose and to innovate toward it, and the other would be to circle the wagons and protect their budgetary base. Albrecht believes in his book and states that NASA's response to the Cold War end was to circle the wagons, to play defense, if you will. And if you play defense, you're not likely to feel the same pressures, the same mission pressures to innovate, as if you're accepting a purpose like going to the moon, which bends the technology curve to suit the necessities of that particular purpose. So here's a case which, if retold through the innovation model, suggests that purpose did not have the desired effect. And I have one more. I'm always impressed by the degree to which the science community just keeps plugging away with new missions that carry out great innovations. And they do that in the name of getting as much science as possible out of the particular mission. Since there are usually 20 proposals for every new start, it's a very competitive situation, and one that gives rise to great pressures of innovation because of the perspective of trying to satisfy a particular purpose. That's Carl Sagan with the Voyager spacecraft. Voyager was started as a grand tour mission to 5 outer planets, at least $1 billion mission. The Congress cut that back to $360 million. NASA gave the project to the Jet Propulsion Laboratory. What the Jet Propulsion Laboratory did, because it was committed to the sense of purpose of science, was they built 2 spacecraft for roughly that price that could go all the way to 4 planets in combination. And the way they did that were some of the factors that are listed there. A very long-lived power generator. And interestingly enough, they made a decision not to contract out the project because they felt that by contracting out the project, they'd waste money. They'd spend more money on the project than if they did it in-house. There's a government maxim that says that you should save 30% of the project cost by contracting it out, but when confronted with this particular mission, NASA decided that they'd save 30% or so by doing it in-house. So in this case, science provided that impetus for innovation. Now let's take a look at calculated risk-taking. This is one of my favorite photographs. It's the photograph of the, I have to read this, Lunar Landing Research and Training Vehicle, but everybody called it the Flying Bedstead. Maybe you remember the picture of Neil Armstrong flying this and losing control, having to push the ejection button. He went flying off of the bedstead, his parachute opened, he swung once and touched down on the ground. If the bedstead had been tipped at a slightly greater angle, the parachute wouldn't have opened in time, and Neil Armstrong wouldn't have been the first person on the moon. NASA pilots and astronauts crashed 3 of the 5 models. That always struck me as risk-taking, as a willingness to endure failure in order to accomplish innovation and growth. Venture capital is often a way that risk is measured. The model for venture capital is up on the board, but the essence of the venture capital model is this, that the money lost on failed enterprises, like the one we saw last night, is less than the money gained for the ones that succeed. And if you make that assumption and it works well under venture capital, then you come out ahead on the innovation curve. But that raises a fascinating question, since half of the money that's spent on research is spent by the government. Is the government a good venture capitalist? In other words, is it willing to endure the risks that occur and to make the calculations that ensure that the risks are less costly than the gains from innovation? And so I give you Solyndra. This has been in the news recently. It's one of 26 venture capital loans. Now, if it works according to the model, not all 26 should be successes. In fact, more than half should fail and go bankrupt. And Solyndra did. And what happened? It moved into the political realm, and the Department of Energy is being punished because of a failure. The underlying philosophy of venture capital is that you're supposed to have failures. So you would want to reward a failure. You'd want to say to the Department of Energy, that's great. We're glad to see that you had a failure because that's making the model seem to work. But that's not what's going on. And it may be that the investigations are turning up factors that a venture capitalist wouldn't make those kinds of decisions if they were playing with their own money. For example, making sure that there's a venture capital contract in every congressional district. That's a factor that someone playing with their own money wouldn't necessarily follow. So this incident raises questions, and people, I remember from my culture study inside NASA, people inside NASA said they won't let us take risks anymore. Risk-taking is an essential component of innovation, and it shows up in all the courses. Whether or not government is capable of that with the political situation is an open question. And so what's going to happen with the commercial spaceflight initiative? Lots of competitors, seed money, which is the government acting in part as a venture capitalist to advance the causes of those companies, and hopefully a few of them will fail. Maybe many of them will fail, but the ones that succeed will develop technologies that will advance the overall mission. The overall mission in this case is to do what the space shuttle was supposed to do, to cut the cost of access to space. The private sector may be able to do that. It may be able to innovate, and Elon Musk thinks that he can launch people to orbit for $133 million per launch. That would be a considerable advancement over the space shuttle, which at the end of its operation was costing $800 million or more, depending on how you wanted to price it, per launch. But we have the open question of whether or not the government's going to be able to endure the risks that are necessary to make these advancements. And the most recent thing I heard was that that NASA had decided to use a contract method of procurement rather than a seed money method of procurement. I haven't had a chance to really investigate this, and Elon Musk has complained that if the government makes that decision, then he'll have to set up a bureaucracy that will drive up the costs in order to comply with the contracts. I think his idea is like Amtrak. If a civil servant wants to go to New York, come on in and buy a ticket, so that any cost of compliance is internalized to the company and isn't driven by outside factors. So I just put a question mark up there because I don't think we know what's going to happen. Another factor is technical discretion. That's a picture of President Kennedy's visit to the Marshall Space Flight Center. It's a famous incident. It's in John Logston's new book. This is where I got the quotation from that made me think that I was on the right track with respect to this. At any rate, an argument broke out at the Marshall Space Flight Center over lunar orbit rendezvous. NASA was already committed to it, but the president's science advisor objected, and it just broke out in front of President Kennedy. I think he encouraged it. He said something like, I understand my side that Jerome Weisner doesn't exactly agree with that point of view. And then the fight started. So here are some of the principles involved: Kennedy, Lyndon Johnson, Wernher von Braun, Jim Webb. And they argued in front of it, which made Webb very nervous because he thought that the president could overturn that particular strategic decision. But Kennedy didn't. Kennedy was a believer in letting the best and the brightest figure out how to run wars and run the space program, and he deferred to his technical experts. So technical discretion is an important part of innovation in government and non-governmental programs. A good example of that is the Kelly Johnson Skunk Works at Lockheed during World War II, where Kelly Johnson insisted that the Lockheed bureaucracy and corporate hierarchy leave him alone and just put him in a tent on the backside of the manufacturing plant lot and develop his jet engines and his jet plane fuselage back there. By contrast, the shuttle decision did not provide people in NASA with as much technical discretion as they possessed during the Apollo decision. Is that a fair statement, John? And so here's a picture of Jim Fletcher showing the only model of the space shuttle to Richard Nixon in San Clemente in January of 1972. Nixon wouldn't give it back, by the way. I think there was a story about that, that they sort of wrestled for the model. Fletcher had to take it back with him to Washington, D.C. Nixon agreed at that point with the White House advisors and attendants that the cost of the shuttle would be $5.5 billion for phase one. And if you look at the picture very carefully, you'll note that the boosters on the side of the external fuel tank are taller and thicker than the actual ones on the shuttle configuration. That's because they're liquid fuel boosters. Fletcher got in an airplane and flew back to Washington, D.C. By the time the airplane landed at Andrews Air Force Base, the price, had gone down to $5.15 billion. In order to accommodate that cut, Fletcher decided to substitute solid rocket boosters for liquid fuel boosters. It was a decision precipitated by political and budgetary considerations that he would have not made for technical decisions, for technical reasons. And I remember interviewing Fletcher once and being surprised when he said that he thought it was his greatest mistake, that he didn't stand up to the budget examiners and say, well, if that's the way you want to price it, I can't build it for that. You'll have to get somebody else to do it. And he said Nixon would have gone back to the 5.5 under those circumstances. So people worry in my community in public administration that political and bureaucratic pressures supplant technical discretion on programs like the space program, and they're committed to the idea that technical discretion is essential for innovation. One more, imagination. Imagination takes place when people have visions that they create out of odd associations, like the winged spaceship in 2001, A Space Odyssey, which has on the side of it Pan American Airways. It was a privately run shuttle, that somebody can take the concept of an airplane and transfer it into a spaceship and then address the technical difficulties that are necessary to create that, and along the way motivate people to follow the vision. I never found, when I interviewed people in NASA, that they were excluded from the capacity for imagination. What I did find was that there were limits on their ability to motivate people to follow their vision. And those motivations during the 1970s and 1980s arose from a peculiar characteristic of government policy making in NASA. That is that NASA was not allowed to defend programs for the future on the basis of future goals, but rather had to defend them on the basis of past programs. NASA and the government as a whole for civil space adopted an incremental space policy that allowed people to agree on programs without agreeing on their purpose. And from that we got things like the Space Shuttle and the International Space Station that were politically popular, but they didn't make sense in terms of what the long-range goals for space were, because there were no long-range goals. And I can recall people in NASA telling me that they made a strategic decision not to defend the space station on the basis of what it would be used for in the future, but rather to defend it as the next logical step on the basis of a program that was already in place. And limitations on motivation are a factor that is not supposed to influence people in the private sector in developing support for their visions. So here we are again. Can governments innovate? Well, the first question is, do you have any choice? NASA's budget is fixed. We're not going to get more exploration unless we do innovate. And the second point is, government spends so much money on research that you can't imagine a non-innovation policy. So here we are. Public servants know how to innovate. There are factors that favor innovation. There are examples where those factors have come into play and have encouraged innovation. And if we think in these terms, then I think we have a new way of presenting space history that furthers our understanding of the factors necessary to innovate in the future. With a cartoon. Can you see it? I miss NASA manned flight, it says. They're going through airport security on the way to the spacecraft. So we do have examples where factors interfere with innovation. Is governmental innovation an oxymoron? Well, in part, yes, it is, but it doesn't have to be. If people would pay as much attention to the factors that promote innovation as they do to the factors that promote good rocket science and good aerodynamics. That was sort of where I came out when we looked at these factors. So let's open the discussion and see if this is a useful way of thinking about programs that affect and encourage innovation.